Hello! Example number 2 of long division of polynomials. Best stuff ever. Look, I know it's hard, but the good news is it's doable. You're going to multiply and divide, subtract, multiply and divide, subtract a whole bunch of times. And that's the rhythm. Multiply, divide, subtract. Now, first thing we're going to do though is we have to make sure that we have the stuff under the division sign in that symbol, that we have it written correctly, and it needs to be in standard form. So highest exponent first, x to the fourth. Then we need to put a placeholder for any that are missing. Like right now there's no x cubed, so we need a 0 x cubed. I know it sounds crazy, but trust me. And we're going to need, we don't have an x squared, so we're going to need a 0 x squared. And there's no plain x, so we need a 0 x. But then we do have our handy dandy negative 81, minus 81. Okay, so we're going to pull off the same steps we've done before. So we're going to start by dividing the first term divided by the first term. So let's do this in another color. So let's do x to the fourth divided by x. First term divided by first term every time. Well, x to the fourth over x is just x cubed. One of those x's up here cancels out with that one. So now, I'm not sure why this is there. Maybe that's a little bit better. I'm trying to fix this so it doesn't jiggle so much, but sometimes it happens. So x cubed here. So the x cubed, and again, you're going to line it up above the one that's similar, a like term, just to keep things straight and simple and helps you organize things. So after we divide, we multiply. The answer you just got times what you're dividing by out front is x minus 3. And that equals, let's see, x to the fourth minus 3x cubed. Okay, now remember, what do we do next? We divided, then we multiplied, and now we subtract. I'm going to write it over here though. So I'm going to subtract x to the fourth, and I'm going to subtract a negative 3x cubed, which really means plus 3x cubed. X to the fourth minus x to the fourth gone, 0. Now 0x cubed plus 3x cubed. Well, that's just 3x cubed. 0 plus 3. And then we drop the next one like it's hot and do it again. And again, we're going to divide, multiply, subtract. So first we divide. First term divided by the first term. Let's see, one of these x's up here cancels out. We still got that 3, so 3x squared. Put that up top. Okay, we divided. Now we multiply. Yes, that's right. 3x squared, what we just got, times what we're dividing by, the x minus 3. And that gives us, in this case, 3x cubed minus 9x squared. Divide, multiply, subtract. So now we have to subtract what we just got. So minus 3x cubed minus a negative 9 would be plus 9x squared. And then divide. I'm sorry, I did not mean divide. Just kidding, I meant subtract. So we already got the subtract signs in, so we can just add. So 0 plus 9, 9x squared. Now we drop it like it's hot. I'll use purple this time. We're going to do all these steps again. Kind of run out of room, so I'm going to move this up just a little bit. So we're going to divide first term, 9x squared, divided by the first term out here, which is just x. We'll get 9x. Write that answer on top. We divided, now we multiply 9x times x minus 3. And that gives us 9x squared minus, let's see, 27x. You're just distributing this each time as a quick reminder where that comes from. And now we subtract. So we're going to subtract 9x squared. And we're going to subtract a negative 27x. Cancels 27. And then we drop it like it's hot. Let's see, I've used blue, red, purple. Let's use orange. Alright. This time we're not dropping a 0, we're dropping a negative 81. I could do this over here. Is it okay if I use this space for a second? Let's do that. So we're going to, we divide, multiply, subtract. Let's do it again. Divide first term by first term. Whoops. I said first term, but then I was writing more than that. First term over here is x. That's just 27. Write that on our answers up top. Multiply 27 times x minus 3. 27x minus, if you're anything like me, you forget what 27 times 3 is. So I shouldn't forget, but you know what happens. So 27 times 3, 81. Alright, so now we're going to subtract 27x minus 27x. Looks like a dot. Make it a minus sign. Minus a negative 81 is a plus 81. And now we can add straight down, so gone. Hey, that's also gone, so it's 0. So this time the remainder was 0, which is kind of sweet. What that tells us, if the remainder is 0, is that means that this crazy thing, x minus 3, was actually a factor of that polynomial. Since the remainder was 0, that means this original thing we divided by was a factor of the polynomial. It divided out very nicely without any remainder. Kind of cool. There you go. We did it.